good afternoon, good evening to everybody. I know that we are from different time zones. My name is Dr. Lilian Mulamula. I teach at the University of Dar es Salaam. Specialize in ecosystem management and climate change. I feel honored to be one of those who will be leading this lecture today. And I'm joined by Professor Karin. Professor Karin, if you can greet the participants, please.
Yes, thank you very much. Yes, I'm also very happy to be joining today from the Netherlands. My name is Karin Rebel. I am a professor of sustainability science and education, focusing on climate change and especially uptake by CO2 by natural systems. And I'm very happy to do today's lecture together with Dr. Lilian.
Okay, thank you, Karin. We're actually very happy that we are beginning this module, this climatized course. So we are happy to have all of you here. I understand that we are supposed to be having like 10 universities from Africa and one from Europe. So such an exciting opportunity to come together and discuss on these climate change issues. And actually this clearly shows that climate change is one of the issues that connects us all. So we come together in one table and discuss this matter. So today's lecture is on climate crisis, and I'm going to share it with Professor Karin. So I'll be taking you through, and at some point I'll be welcoming her to guide in some of the slides. So it will be a co-sharing session. Welcome all. I think I'm going to share my slides first. Can you see my slides?
Yeah, we can see your screen. You can see the
Are they in a presentation mode or? Okay.
Now it is in presentation mode, but yeah.
Okay.
Yes.
Okay. Welcome all. Like I said, today's lecture is on climate crisis, and it's going to be delivered by me, Lilian Mulamula, and happy to have Professor Karin also, who will be also sharing her expertise on the matter. So I know that climate change is something that is happening every day, and we are living in it today. And just to begin, I would like to get a quick comments from all of you. If you can tell us a bit, when you hear on climate change, what comes into your mind from where you are? I know that some people are from West Africa, some are from East Africa, some are from different parts of the world. When you hear the word climate change, what comes into your mind in the context of where you live? If you can have 2 or 3 answers from participants. What comes to your mind when you hear the climate change from where you live? Students, Mwandi, you kindly help in.
No.
Okay, Fatal.
Okay, so I'm Fatal Idrisu, and I'm speaking from Ghana, West Africa, from KNUST. And with climate change, my personal opinion would be on the change in the, should I say, weather patterns, the rainfall and precipitation, the normal or expected times that we expect these rains, and then precipitation would differ owing to the fact that the vegetation and then the plants around our should I say, places are being removed for industrial and then routes and some other infrastructure that changes the rainfall patterns and all those things. So that's my personal, opinion about climate change. Thank you.
Okay. Thank you very much, Fatal. Any other? Just a short picture you get when you hear that there is climate change. People, let's say, for example, people in your village, what do they think when they hear of climate change? For instance, in my village, people think, oh, there'll be no bananas and no maize this year. So what do people think, or what picture do they get once they hear the climate change from your context, from your local context? Any other student?
I speak from the Netherlands. I'm Angelo. I'm from the University of Utrecht. If you were to ask the average Dutch person about climate change, I think there's two really main topics that would come up. The first is the freezing of the canals. So years ago, it used to be fairly common that for a week of the year you would be able to skate on the canals. There used to be a competition that they did within cities where you'd skate from one city to the other. But now the canals rarely freeze over. And the second thing is sea level rise and storms. So a lot of the country is below sea level, and there's a lot of infrastructure to keep the land dry, but that infrastructure is increasingly under strain and needs to be adaptive. So I think those two things would probably come to mind the most here.
Thank you, Angelo. Thank you very much. One last person. What comes into your mind, or what comes into your community's mind when they hear of climate change?
I'm Musa from Kenya University. So on this side, when you hear of climate change, we also think of extreme weather conditions, such as heavy rains, drought, and some storms. What comes in our minds is always extreme weather conditions on this side. Thank you.
Okay, thank you. Thank you very much. So basically, from what we have heard from the Netherlands, from Africa, it's more like we're experiencing different extreme weather conditions. And some people would think of it in the form of its impact. Some would think of the direct impact, like the way they experience maybe too much rainfall or too much temperature. And some also would think of from the indirect impact, like, okay, this means we're experiencing some hunger or something. But basically, you can see that climate change is one thing that connects us all. And we experience it differently in some cases, but at the end of the day, it connects us all. Now, our lecture today will take us through five key areas. What is talked about in the news when it comes to climate change. So like, as we have shared from our local context, then what is happening in the news? And then we'll go through what is actually happening now as far as climate change is concerned. Why is it happening? Why is it a crisis? And later on, we'll discuss on the responses. Is it too late? Can we still do something on climate change? Now, quickly, this is what's happening in the news. For example, from Africa, this is news that was published in February 12, 2026, capturing what is happening in South Africa, for example. Farmers were complaining they have lost their cattle to drought. And this was reported. So some parts in Africa are experiencing drought, some are experiencing other extreme events, and this is what is covered in the news. Another example of what is being covered in Africa is, you can see there in Kenya, for example, their president has been pushing for expanding climate financing, showing that there is a need to respond to the climate change but there is also some needs on climate financing, particularly in the developing world. So this is what was covered in that news. But at the same time, there are some news covering on the efforts. For example, this source of news known as AP New Media reported on what is being done in Nigeria and Kenya with regard to trying to reduce the greenhouse gases, and that it reports that Nigeria and Kenya lead Africa's push for electric vans that are assembled from Chinese kits. So you can see that climate change is also on the news. Now, this is part of Africa, but some news are also covered in developed world, in Europe, for example. Professor Karin, if you can tell us a bit on what is being covered in Europe.
Yes, I also checked the news this week, actually yesterday. And of course, you can do this about every day. What we currently see within Europe is extreme rainfall in the area of Spain, where it normally is very dry. Meaning that also the soils are very dry, but now with these extreme rain events, there's a lot of extra rainfall and very rapid increase of water table depths, which actually make the soils very unstable. So this is something that is currently very much on the news within Europe. But I think if you can go to the next slide. What is also, of course, very important is not only what is happening within Europe, but globally. And I think this one is also very important, where this week we saw that the Trump administration is actually limiting their government's power to limit the emission of CO2 by basically saying that CO2 is not responsible for climate change and not responsible for the temperature rise. This, of course, is a very important thing that's in the news, also because it limits the ability to limit the emission of CO2. So this, I think, is also important. When we look at these global trends, then we really also see the different news globally, where it is what's happening.
Okay, thank you, Prof. Karin. So basically, it's in the news everywhere. There are some efforts going on, but unfortunately, some are pushing forward, some are pushing backwards, but the impacts are also felt everywhere. So before we go further, I think it's very important that we remind ourselves of some of the key, very important terms that we usually use so that we are on the same page. And that is, are we experiencing climate change, or are we talking of weather? So we thought that it's very important to have these definitions at the beginning. So weather, what is weather? We have two important things. We have weather and climate, like I said. So weather is the short-term atmospheric conditions in an area at a specific time. Like what we have experienced today, for example, in Tanzania, we are experiencing some warm weather today, and there had been a little bit of rainfall. I know it's different in the Netherlands. It's probably very cold today. And maybe tomorrow we experience more sun in Tanzania. I don't know what will happen in Netherlands. So that is weather, just short-term atmospheric condition. Like, for example, on that picture there, you can see that, okay, what happened on Monday, what happened on Tuesday, Wednesday, Thursday, and Friday. Maybe Monday was sunny, Tuesday had been a little bit cloudy, Wednesday had been very cloudy, Thursday a little bit of rainfall. So that is weather. On the other hand, what you're talking today is on climate, and that is long-term patterns of elements of weather in a specific region over a long period of time, and typically it's considered for years, 30 years average. how is the pattern going on? Is it increasing? Are there some abstract changes or whatever? So that is the climate now that we're interested in, not just whether yesterday was rainy, today is dry, and all that. And if you're talking of the climate, then what is climate change? Climate change now is change in the state of climate that first can be identified and acceptably is by statistical tests. And once these statistical tests are done, it has been established that there has been a change in mean of its properties, and that change has persisted or extended for an extended period of time. Like I said in the previous slide, typically 30 years or more. And that change can either be due to natural changes or natural influences, or it can also be due to human activities. But as long as the the average has changed and it has persisted for some time, then that is climate change. So in a simple word, it can be said to be the long-term shift in the Earth's average temperature and weather conditions. Now, I know this term climate change has been heard. Now it's not a very new term to majority of people. We all live and hear this term very frequently. But some people might be have been confused. Okay, so what is happening? Is it like maybe the sun is giving too much heat now as compared to the previous time? Or what exactly is happening? And scientifically, this is what is happening. First of all, we have to remind ourselves that what is causing this, the change, is the greenhouse effect. And this greenhouse effect is caused by the greenhouse gases. Greenhouse gases are a very important component to support life on Earth. Why? It's because it's like a blanket that keeps us warm. So naturally, life on Earth needs the presence of greenhouse gases. And this results into the greenhouse effect. And so naturally, the Earth would receive some sun radiations from the sun. And once they receive it, it will absorb some of it and some will be radiated from the Earth. And with the natural coverage of the greenhouse gases, what will usually happened in the past was that the atmosphere would have trapped some of the heat and would allow some also to escape from near the Earth. So some would go out to space and some would be trapped. But then by the end of the day, we would have quite a lot of heat trapped, enough to warm the Earth and support life. So naturally, greenhouse gases have been there, and they are actually a very important component to support life on Earth. But what is happening now is what we refer to as enhanced greenhouse effect. What happens is that the atmosphere has more greenhouse gases than it needs. And for that matter, the radiated heat from the sun is still there, but less is being allowed to escape to the space, and more is maintained. And for that matter, we have more heat than we want. It's like we are warming ourselves more than we want. I don't know, my slides are not moving, Mwangi. Okay. Okay, thank you. They are moving now. So atmosphere at the end of the day traps more heat and less is allowed to escape. As you can see, the difference in this in the arrows effect and enhance the greenhouse effect. So less heat goes out to space, more heat is trapped, and this causes global warming. And in a nutshell, in very simple pictorial presentation, it's like what is being shown there. It's like the earth is somewhere there laying and it's being covering itself with some blankets. Maybe it needed just a single blanket or a very thin one to keep it warm enough for comfortable life. But what is happening now is like we are adding more and more layers of blankets. And for that matter, the earth is like feeling too hot and it's realizing that
I think Dr. Lilian, are you here?
I think she has dropped off. Maybe she's having some internet connectivity issue.
Shall I continue with the next few slides and then, or shall we wait for her to come back? Ah, there she's back.
Oh, yeah, she's back.
Yeah.
Kindly unmute yourself, Dr. Lilian. Kindly unmute yourself, Dr. Lilian, if you can hear me. Hello, Dr. Lilian, we can see you, but your audio, maybe you can unmute yourself kindly.
Can you hear me now?
Yes. Yeah.
Oh, thank you. I don't know what happened. Well, and I think you can see the slides as well.
Yes.
Okay, thank you very much. Now, actually, I ended with welcoming you, Professor Karin, to add more on what is happening by explaining the following slides.
Yes. So what we see here, so every year there's a global carbon budget, and every year in November they release the latest numbers. You can also go there yourself. So on this slide, you also see the link to the Global Carbon Project, which was released in November 2025. And here you see the atmospheric CO2 concentration that increased from about 277 parts per million, which is a unit that we express CO2 in the atmosphere, in 1750 to over 420 parts per million in 2024, which is an increase of over 50% over time. So here you also see where this is coming from. So you see that fossil fuel emission causes about 88% of this increase, at least over the last year. And also land use change is responsible for this emission of CO2, and that accounts for about 12%. So important it is to realize that CO2, once it's emitted into the atmosphere, is not broken down. So it's not active in the atmosphere. The way that we can remove it from the atmosphere is only by natural sinks. So in this slide, on the one hand, you see the sources, so fossil fuel emission and land use change. And on the other hand, you see the sinks. So part of that sink is just the CO2 staying in the atmosphere. The other one is CO2 being taken up by vegetation through the process of photosynthesis. And this is about 20% over the last year. And then you also see that quite a bit is taken up by the ocean. And that is through diffusion first. And then there's other processes that take care that this CO2 is actually staying in the ocean for longer term. So that is the uptake, for instance, by phytoplankton, etc. Do you want to continue again?
Okay, thank you. So
yep.
And from what Professor has said, so it's clearly then the key reason as per why this is happening is because of human and natural drivers. So this is one of this image here shows some of the observations that have been done by various models, and you can see the black line. This black here indicates the observed temperatures, and the red line indicates the results of the model that was fed by human natural drivers together. And the same results if natural drivers only were considered. So at the end of the day, it came to, it gave the results that what has been observed coincides very well when the model is fed by both human and natural drivers, indicating that if only the natural drivers were responsible, would be having this trend here, I mean on the green line, but with the human and natural driver, I mean with the introduction of human drivers, this rise in temperatures is what has been observed over time. And this clearly confirms that humans are really having serious contribution towards what is being observed today. So why is it happening? Is because of influence of human drivers. And this image here shows some of the human activities that are really responsible for what is being observed. For example, on the right there, I mean on the left, we have the emissions from industrial activities. Humans are also in the pursuit of development as well. For example, in areas that are rich in forests, they want to clear forests for their own development, but then by doing so, first they're reducing the natural sinks, and then also whatever has been stored on those forests will later on be released to the atmosphere. We are using industrial fertilizers. For example, you can see the farmer on the other side. That image shows the use of artificial fertilizers, and those end up adding some nitrous oxides, which is one of the greenhouse gases. We have issues of use of, for example, burning of fossil fuels through our cars. We are keeping animals, and you know that they are burping. The burping, for example, the cows releases some methane, one of the greenhouse gases. Some of the methane is also released from the dams. So these are just some of the activities that, some of the key activities that ends up adding greenhouse gases to the atmosphere than what the Earth really needs. And Professor, if you can add more on this slide as well.
Yes, so here we look at CO2, and it's very good that you mentioned that it's not only CO2, it's also methane and nitrous oxide. Though the sources over time of these gases have been less well studied or less well shown as here for the CO2. So for today, we will focus on the CO2 and on where do the emissions coming from. And here again, we go to the Global Carbon Project, which then shows the numbers here until 2024. And here you see the total emissions per region. And you see that for total emissions, China has really gone up in total emissions, followed by the US, India, and Europe. It's interesting to see this very sharp increase of China from 2000 onwards. And this has to do not only by their sharp increase in production, but this sharp increase also went along. In that time, the US started to used to use a lot of coal for their production and therefore a lot of emission of coal, but they are now using their gas that is in their soils, in their they are doing this through fracking the soil. And so they are not using as many coal anymore, which really made coal a lot cheaper, which was then used by China right around 2000 till 2010. And there you also see this very sharp increase. But this is the total CO2 emission. In the next slide, we can see the CO2 emissions per capita. So then we divide it by the total number of people living in the region or country. And there we see that the US is still a top emitter, but going down. And it's going down because of its increased use of shale gas, because this is more clean than the use of coal. We also see a rapid increase still by China, and a decrease by Japan and Europe. China is increasing because of its increasing production. It's producing a lot of goods for the rest of the world as well. So we have to take into account that this is only production. So the production and the emission of CO2, not the consumption of goods that are being produced in these regions. If this would be the case, then we would see a different picture, but it's not converted for that, because China is producing a lot of goods, both for the US and for Europe. So they would increase their emissions if we would correct for this.
Okay, thank you very much, Karin. So then, if that's the reason that that climate change is happening, then it's very important to have a reflection. Then, okay, this is happening. Why is it a crisis? And as you can see in this slide here, this again also reflects some of the news that have been covered in various parts of the world. And this clearly indicates why this is a crisis. Number one reason being, it's a crisis because climate change, first, as it is, results in global temperature rises. We are talking of global warming. That means too much warming. So number one crisis is the too much warming. global temperatures are rising to record high, and this is having some impacts globally. Some areas experiencing some droughts, for example, in this news in the middle from BBC, indicating how the West Africa was hit by a deadly heat wave. And science and actual records show that that was impossible without human-induced climate change. That's what scientists said. So number one reason is a crisis because global temperature are rising to record high. On the other side, we have what has been experienced in South Africa. There had been a global, this news say that South Africa on the brink of global heating disaster. So too much heating, people were experiencing too much heating, threatening life. So it's a crisis. It's too much warming than we want, too much temperature to record high. On the left there is a picture from The Guardian showing how rising heat kills 1 person a minute worldwide. That was a report. And if this is the reason, this is what is happening, then definitely this is a crisis. So it is a crisis first because we are experiencing too much temperature than we want, and not just too much than we want, but it is a record high. We'll see on the graphs that will come later. But also, it is a crisis because that what is being experienced is affecting also on food and water securities. We know that climate change as it is a direct cause of soil degradation. For example, if there is less rainfall, that means we are reducing soil moisture. No soil moisture, definitely the soil grade is lowered. The soil productivity is lowered. So that means the soil has been degraded to an extent that cannot support the agricultural activities. So also, if there is too much rainfall, that means there'll be some breaching, for example, and that means will affect nutrients availability. If too much rainfall again, it might result into erosion, soil erosion. And in agriculture, it's the topmost soil layer that has too much nutrients. And it's also this very topmost layer that supports growth of crops. So if soil erosion, for example, comes as a result of too much rainfall, that means also the nutrients will be taken away. So at the end, what does it mean? It means the soil has been degraded. But also, it results into loss of vegetation. And if we reduce the vegetation, it means the plant cover is lowered. Then we're exposing the soil to erosion. And also, we are decreasing the possibility of input of organic material. Again, what does it mean? It means we are reducing the soil quality. And also another example on how this results in food and water insecurity is from the fact that if we are having prolonged drought and loss of vegetation, some areas will end up turning into deserts. And if it has turned into desert, then the possibility of recovering the quality of that soil becomes even more minimum. And with water security, it's very obvious that if we're having less water, that means we're limiting the availability of water to support drinking, for example, in agriculture. But also, if we are having, for example, vegetation is affected, that means we're also affecting the entire water cycle. Again, the availability of water will be jeopardized. So it is a crisis also because of what it does to our food and water availability. Climate change is also a crisis because it results in new extremes that either had never been experienced before, or probably the rate of these extremes occurrences are increasing. And that means we're experiencing some disasters, more disasters than we want. So disasters that are linked to climate change and weather extremes have always been part of the FE system. But what's an issue now is the frequency of their occurrences. And unfortunately, no continent is left untouched. Some continents might experience some heat waves, some will experience the drought, some other areas will experience floods, cyclones, typhoons, and a number of other mass destruction disasters that are occurring around the world. And according to the United Nations, according to UNEP, they concluded that nearly 90% of disasters that are now experienced are classed as weather or climate related. Why is it a crisis again? Another issue is that it is a catalyst for conflict. And this is very serious, particularly in developing world. But of course, some conflicts can also go even in the developing world. But with climate change and these extreme experiences, competition for resources are rising. For example, in the previous slide, we said that there would be land degradation. That means fertile land will be limited. What does it mean? Everyone would want to benefit from that limited fertile land. If food is limited, what does it mean? There'll be definitely some conflict on the limited resource that is available. So it's heightening the competition for resources that are available, resulting in socioeconomic tensions, and sometimes it will lead to mass displacement, whereby people will have to move from one area to another in search of their needs. And unfortunately, in the majority of these movements, sometimes they result into even far more conflicts. For example, what is being experienced among the pastoral and farming communities, sometimes pastoral communities might have to move in search of pasture for their livestock. And as they are moving, they would pass through the farmers, resulting into conflict for example, the cattle would not see those plants as somebody's property. They would just end up eating, for example, the maize and whatever, and results into conflicts. So basically, we can say that climate change is a risk multiplier that ending up making what is worse, even more worse. For example, these are some of conflicts that have been exacerbated by the climate change. For example, Somalia crisis has been worsened between clans because of water and grazing land. And unfortunately, some of the terrorist groups took advantage of that by controlling aid and resources. Also in Sudan and South Sudan, drought has worsened the already existing tensions between farmers and herders, thus multiplying the conflicts that had already been there. In another part of Africa, on the Mali and Sahel region, there had been significant droughts recently and have made farming and herding harder, pushing young people towards armed groups for survival. In Nigeria, I know there have been some reports of the shrinking of Lake Chad, one of the very important lakes there. And the lake had been shrinking. All those groups of community that were depending on the resources now fight over the available water. And that means the fishermen, the farmers, and herders. And that's usually such situations, in case of those areas, they are having some extremists, then they take advantage of that and becoming more stronger. But also, climate change is not just affecting the human directly, but also it has some impact on biodiversity. Of course, we acknowledge that the main driver of biodiversity loss remains on humans' use of these resources, but climate change is playing an increasingly important role in the decline of biodiversity. For example, you can see from the statistics that have been shown from the image there, if we limit the warming to 1.5 degrees as per what is envisioned by the Paris Agreement, then 4% of mammals would lose half of their habitats. But in case we fail and reach 2% increase of the temperature, that means nearly 8% of mammals will end up losing the half of their habitats. And if we go further, we might end up having 45% of mammals losing half of their habitat. And not just that, so climate definitely is altering marine, terrestrial, and freshwater ecosystems around the world, and resulting into loss of local species, increase in diseases, etc. And so recently, scientists are arguing that we are probably leading into the climate-driven extinction, and that is alarming. And this image here shows what is also is expected with the biodiversity loss. For example, if we are just to succeed by not exceeding 1.5 degrees of centigrade increase, the color, if you can see the key there, the yellowish to the more like red shows the varying average percentages of biodiversity loss. So if we succeed in around 1.5 degrees Celsius of the increase in temperature, you can see that the colors are not as deep as if we increase by 2 degrees of centigrade. So with every increase in temperature, the percentage of increase of biodiversity loss increases. And if it happens that we lose, we reach to the, I think that will be the fatal level. For example, the 3 degrees of temperature, 3 Celsius rise of temperature, you can see that majority of the parts of the world will have lost from 50 to some to 100% of the biodiversity. Hoping that will not reach there, so we have to put our efforts in ensuring that we do not exceed 1.5 degrees as what has been envisioned by the ongoing efforts, for example, through the Paris Agreement. Professor Karin, if you can add something on that as well.
On the Paris Agreement or on this slide?
No, in this slide.
Yeah, so I second what you just explained, and perhaps it's good to see that here it's all kinds of biodiversity losses. So it's plants, it's animals, and yeah, it clearly shows that it's not equally distributed globally. So some regions are much more vulnerable than others, but also I think it shows quite clearly that we really, as you were also saying already, really would like to stay at a temperature increase of 2 degrees, but not more, as there you see the big risks are coming.
Okay, thank you. So this slide also shows some of what will be experienced in the biodiversity. And for example, some of them are very sensitive. For example, the coral reefs, whereby every fraction of a degree increase matters. If we limit at 1.5 increase, then still nearly 70 to 90% of the corals will vanish. But if we go to 2, nearly 99% of corals might end up being vanishing. Now, maybe a question to ask ourselves, is it too late? We have a very important quote from Antonio Guterres, the UN Secretary General, who said that the climate emergency is a race we are losing, but it is a race we can win. So think among yourselves, do you think this statement makes sense? Do you stand with Antonio Guterres? But this is what he believes. The climate emergency is a race we are losing, but it is a race we can win. What does science say? This graph here shows first what science says with regard to the increase in temperatures, that it's obviously, and it has been proven, that global mean temperatures are rising above average. And the recent statistics shows that 2024 has been the year with a global mean temperature of more than 1.5 degrees Celsius above the pre-industrial era. And so it's the warmest year. It actually recorded the warmest temperature ever. However, with 2025, it's lowered a bit. And so this had been the second warmest year in records. And moving from 2023 to 2050, these three have been the warmest years, with an average of 1.48 degrees Celsius, Celsius above the pre-industrial era. And moving from 2015 to 2025, the past 10 years, are also being reported as the 11 warmest years. So science shows that warming is continuing, but it's not like the governments are silent about what is happening. What are they doing? There are some efforts that are going on. For example, we know that in 2015, countries, leaders of more than 98% of countries in the world met in Paris and agreed to limit global warming to well below 2 degrees of centigrade. And ideally, they want it to be around 1.5 degrees of Celsius above the pre-industrial levels. So they had some commitments they did, including submitting their commitments on the reduction of emissions. And every 5 years, they will look at what they have achieved and whether they need to review their commitments in reducing the emissions. And they aimed at reaching carbon neutrality by the mid of this century. That means by 2050, we would have net zero if we are to achieve the 1.5 increase. But also these global leaders talked on what can be done to particular developing world. So some committed on offering financial and technological support to the developing worlds. And all in all, they would promote global cooperation. And also, it's good to remember that governments are also meeting every year to discuss their climate commitments through the UNFCCC Conference of Parties. Yeah. So now, what does science say with these agreements on limiting the increase by 1.5, by an increase of 1.5 only? You should not exceed that. science shows that the goals are alive, but actually the window of achieving them is closing very rapidly. So it's like we are having a live Paris Agreement, or the Earth is alive, but it's on life support. Like what this image there is trying to show, that the Earth is actually on life support. So the Paris climate goals are alive, but on life support. And like what Guterres said on the quotation that we had there, it's a race that we are losing, but we still have a possibility of winning, because even if it's life, someone is on life support, there are some possibilities of becoming healthy again and continuing to live. So again, so with Paris Agreement, like I said, the agreement was to limit well below 2 and not exceeding 1.5. So Professor Karin, if you can explain on these pathways to achieving these ambitions.
Yes, thank you. So in this slide, we basically see 3 screens. And most on the right, you see these bars with coral reefs, extreme weather, and yield loss, and different colors ranging from yellow to purple. And this shows the sensitivity of these systems to an increase in temperature. And here you also clearly see that the coral reefs, as Dr. Lilian was already showing, are very sensitive to a temperature increase. So already a 1.5 degree increase is really hurting them. You also see that with extreme weather and yield loss, it is quite sensitive to a temperature increase. And the horizontal bars that you see over it are the temperature increase in blue of 1.5 degrees, and in light purple of 2 degree increase of temperature. And then we hope that we stay relatively in the less sensitive parts of that temperature increase for at least the extreme weather and yield loss. And if we go to the middle screen, there we see, okay, since 1850, how much carbon or CO2 can we emit to stay below this 1.5 or 2 degrees. And this we can calculate, as it's a physical process, and we can do this with models. And so there we can see, if we want to stay below 1.5 degrees, there's very little CO2 that we can still emit. But also, if we want to stay well below 2 degrees Celsius, there's very little CO2 that we can still emit. And that is shown in the most left slide. There you see the emissions of CO2 on the vertical axis and time on the horizontal axis. And the black line is the current CO2 emissions. And if we stay within our current policy and the NDCs that have been proposed during the Paris Agreement, then we are showing the red line, including the uncertainty around it. And you see then that we emit more CO2 than we can emit if we want to stay well below 2 degrees. What we need to do if we want to stay well below 2 degrees is that we really have to reduce CO2 emissions shown in this left-hand panel by the blue and the light purple line. Thank you for showing. And you see then that there is a rapid decrease in CO2 emissions. So mainly a rapid decrease in fossil fuel emissions. And this is very time sensitive. We have to do this rapidly, because if we don't do this rapidly, then we have emitted too much CO2 in order to stay below 2 degrees Celsius. And then at the IPCC, but also in the different COP meetings, they said, well, if we overshoot So if we emit too much CO2 to stay well below 2 degrees, then we have to do something different. We have to come up with negative emissions. So basically, we have to take up CO2 from the atmosphere. And this is a very interesting but also difficult solution. So what is this negative emissions? So basically, I showed you before that vegetation is taking up CO2 because of photosynthesis. So you plant trees that are growing, then you harvest these trees and they have all the CO2 captured, and you burn these trees for the production of energy. But rather than letting that CO2 go out in the atmosphere again, you capture that CO2. So you don't let it go into the atmosphere, but you capture it and you bury it underground, for instance, in old gas fields. The problem with this technology is that it's not it's still very experimental. And so it is definitely not applicable at a very large scale at the moment, and it's very energy intensive as well. So a lot needs to be done in order to reach these negative emissions. And therefore, we really have to reduce CO2 emissions rapidly to stay below that 2-degree increase in temperature.
Thank you very much, Professor Karin. Sorry. So now, again, is it too late? The good news is that there is still hope for the Paris Agreement, as what had been reported last year. And this was is what has been reported at the COP, whereby it was reported that so far, with all that had been the nationally determined commitments that were submitted by countries, members of the Paris Agreement, if their commitments are being observed, then there is a possibility that the emissions will be curved downwards, as you can see in this arrow here. And that means we might have a reduction of 12% emissions by 2035 when compared to the levels of 2019. So there is still hope for the Paris Agreement. And if that would not have been done, then this would be the emissions on the red. So we are bending down the emissions curve, even though not at the rate that had been planned before, but at least there is still hope on the commitments by these various members who have agreed to work on reducing the emissions. And again, we have very important quotes from the UN Secretary General. He said that one thing is already clear, and that is we might not be able to contain the global warming below 1.5 degrees in the next few years, but there is still hope that we can bring back down to the 1.5 target by the end of the century. So there is hope. And it's important to remember that while we are talking of these major changes that are coming through the government commitments and businesses, but individuals, me and you, we can also help. So Professor Karin, if you can guide us through this thinking on how we can do to help, please.
Yeah, by thinking about what we can do ourselves and how also we look at the world around us, sometimes it's also good to first think about what's currently happening and what do we find strange or even absurd of the current situation? What is it that would you really like to stop with right now if we look at the world and at ourselves? And perhaps you can all think about this a little bit. What is the absurdity of the present? What is it, if I look around me related to climate and climate change, what is it that is really strange and you would really like to stop with? And perhaps you can write that in the chat and we can see that coming through the chat and we can see a little bit of a brainstorm of this. So what is it that you look around you and it's obvious we need to stop with this? It's an absurdity. Can you think of some of these things?
If you can write on the chat, please.
And everything is okay. It can be small, it can be large. But what is it that, also listening to today's lecture, that you just feel like, oh, we should just really stop with that, or I should stop with that, or society should stop with that? What is a very strange thing?
There is a comment from Matthew. He mentioned illegal mining activities.
Very good. And are there others? So illegal mining activities, absolutely.
We have Rashida, who said that the amount of tree being cut is absurd in my area.
Yes, and also very important, as we just shown, that this is a sink, an area of a sink. So absolutely. They also see CO2 sequestration and societal proper debris disposal. Sorry. So what do you do with the debris, and where do you store it?
Okay. We have Bruce and Justin. Oh, sorry, not Bruce. Sorry. We have Joel. He asked a question. Sorry, but Rebecca, Zoe, and Ginny say that we are thinking about the use of plastic in everyday activity.
Yes.
And we have Vahu also, who say that emissions from industries. Bruce, more industries being built, emitting toxic gases. Fatuma, carbon dioxide emissions. Mwangi, debris from the construction sites. And Togolai, overuse of trees as a source of energy.
Yes, and Anumu, deforestation, illegal mining, and the use of excessive fertilizers, as Dr. Lilian was also showing that this is a source of nitrous oxide, which is also a greenhouse gas. Musa, the burning of fossil fuels should be stopped. And Joyce, the urbanization leading to cutting down of trees. And again, this is also the sinks, the natural sinks that we are having, decreasing those natural sinks. And Joseph also said the practice of deforestation should be abandoned. Thank you very much for thinking along. Yes, Fosu, you have a question.
Hello, please, Oscar from Ghana University. Please, Prof. Karin, when you were talking about emissions, I think you made mention of capturing the gases and then burying them underground. And my question is, when you capture the gases and then you bury them underground, is it not also going to have an impact on the soil? Thank you.
Yeah, so this is a question about the negative emissions, about capturing the CO2 when we burn the wood for electricity and then putting it underground. So this is still very experimental. It's not yet done at large scales. It's very experimental still, but what is currently experimented with is storing those CO2 in old gas fields. So in these old gas fields, you actually can store, or we think we can store CO2 there for a long time, as it before was storing natural gas. But and this is also the reason why it is difficult to assume that we can do this. It is still very experimental. It's not yet applicable at a large scale, and it's consuming a lot of energy. So there's definitely still technological development that needs to happen in order for us to really do this at a larger scale. For now, if it's okay, I want to go back to this exercise, because I really appreciate that you all thought about these absurdities of the present and what we need to stop with. But sometimes it's much easier to think about what do we need to stop with than it is to think about what is it that we would like to go to. What is it that we as a society would like to go to, or we as a person would like to go to, again, related to climate change? And can you think of this? Can you think of what is it that if it were up to you, how would society look in 10 years or in 20 years? What is it that is really something different? An image of longing. Where would you long to go to if you look further ahead in the future? Can you again use the chat to think about this? What is it that you would like to go to? If you look and think about your own environment, your local situation, but not now, but 10 years or 20 years ahead. Anthony says, I think setting strict rules and executable policies will be somewhat of a stepping stone. And it will be a stepping stone towards what, Anthony? What is it that you would like to achieve? What is it that society would look like in 10 years or in 20 years? Yeah. It's a stepping stone towards what? Can you think of that? And others are also very much invited. What is it that society that we would like to go towards? So not what we want to stop, but what we would like to achieve. Prioritizing renewable energy. So a world where renewable energy is the main energy source rather than fossil fuels. That's a very important one, I think, indeed, as well. But everything is okay. It can be your own personal idea about a sustainable future in terms of climate. Can you think about some others? Alas? I see you have your hand raised. Joyce mentioned, oh, sorry.
It's okay. Yeah, so Joyce is longing to have a world that is well reforested. So he's longing for reforestation. And you have Anthony answering to your question, Prof. You can go on, please.
Yes, stepping stones towards achieving a sustainable achieving sustainable development toward the climate change sustainability, and doing that with renewable energy and with renewable energy sources rather than fossil fuels. And indeed, reforestation, creating many more forests. And Maureen is saying the use of semicircular bunds in areas where there is loose soil and have little rainfall. And this is, I think, to capture the soil, but also to capture the water in certain regions. Very interesting. So perhaps we have seen a couple of these images of longing. What is it that you would like to go to? But can you also then think of some small things that are already currently happening in your region? And can you give some examples of that? For instance, is there something small in your region with small reforestation initiatives, for instance? So Rashida says preservation of forests and water catchment areas. So can you come up with some close to yourself individual or societal changes that you already see that are going towards your image of longing? A fight against illegal mining. Anybody else?
Okay, maybe I can give an example for students to get it easy. For example, in Dar es Salaam, I know that there are a lot of people wishing that they would be able to sleep indoors without having to use fans. And because in some areas, it's very, very hot. So they are allowing that when we reach a day where they'll be sleeping without having to use fans to cool themselves. So they are longing for such a thing. So this is just an example of what is being wished. And I know that there are some people who are working at the mid of the town who are wishing that to have good gardens in the middle of the cities where they can go and sit and enjoy the breeze. Yeah. So these are some of the issues that are really longed by communities where I live. Yeah.
Yeah, I also see that David mentioned establishing a community forest, which is, I think, very important, not only for carbon sequestration, but also for temperature regulation. So when we have forests around, we have shade, and we have lower temperatures. Togolai says improving farming activity. And Crispin mentions encouragement of the use of electric vehicles to reduce emissions of exhaust fumes that accumulate in the atmosphere. And Eve says advocating of soil health and fighting for the abolition of deforestation. And Anthony says, example here in Tanzania, the planting of tree has been set into place whenever a tree is cut down. So basically, if you cut one tree of whatever purpose legally, you will have to plant 2 more, which is of course a wonderful seed of change and a very important one. Thank you for all the different examples that are coming in. I think once you have a few examples, you can also really think and think of some small and larger examples of these seeds of change that can really, even though it seems small, can really make a difference over time. Dr. Lilian, do you want to continue or do you want to move on to the next slide, given the time?
Yes, please. So as we actually remained with just 9 minutes, and we would wish to have at least a few minutes for questions and answers. So having seen what is happening, why is it happening, why is it a crisis, and thinking what is actually something that is happening in our community, the absurdity of present, and what it is that we are wishing. Now, it's important also to remind ourselves on what are the available options for responding to climate change, and that is two very important responses, and those are the mitigation and adaptation options. We'll go in deep through this when we reach module 3 of this course, but at least we know that two very important issues when you're talking of responding to the climate change would be the various mitigation and adaptation options. These images here show some of the mitigation and adaptation options that we can take. And as when we are talking of what we are longing for and what are the available seeds for change, so these can also be some of what we can do. For example, if we avoid food waste, that means we'll indirectly be contributing to less production, less use of land, less ploughing of land, less releasing of stored carbon from the soils to the atmospheres, etc. So first, we can think of avoiding food waste, but also if we can opt for solar power instead of other sources of power that end up releasing greenhouse gases. So solar power, hydropower, etc. So those can reduce the impacts. The release of greenhouse gases. I know one of students responded that they are longing to see that people are walking. They are using public buses, public transport, and biking through the city. So that is also one of the things that you can do to mitigate emission of greenhouse gases. If you can move to electric vehicles rather than those that use fossil fuels, I know that the developing world is doing good in this, increasingly doing good in this, and it's also coming in our side, but this is very important, use of wind power, again, as a renewable source of energy. And there are some options that are shared, for example, building insulation. Okay, or drought proofing so that we don't have to use too much heating systems, smart energy systems, planting of trees, using of local food instead of processed food, etc., etc. But again, it's also important to know that when you're talking of climate change, you also have to think of climate adaptation. What can we do to reduce the risk? Because we are living the climate change. So here are some of the actions that have been shown in this slide, including disaster and emergency planning, greening infrastructure, flood protection, social cohesion, and equity. We come together and work on this, and resilient building designs. I'm running quickly because we have 5 minutes, so I'm not going to go on with this because it will be well addressed in module 3, but it's also important, we thought that it was important to tell you that since we are living in climate change, these are two very connected options, issues that have to be dealt with. And in conclusion, we have to remind everyone that there is no planet B, so we have to protect our planet. We have 5 minutes. If we can use this to receive at least maybe 2 questions from you, and then we can respond before the end of time. If you have any question, please feel free to raise your hand, or you can write on the chat. As we are waiting for the question, Professor Karin, if you have anything to conclude with.
Well, it's of course the floor is still open for questions. I see there's 2 questions in the chat. The first one, I don't know, Dr. Lilian, if you want to take that one, which is the inequality of the historical contribution and how this is being approached by African countries, by Rebecca,
Okay,
Zoe, and Jingy.
Okay, thank you, Rebecca, Zoe, and Jean. That's a very good question. And actually, it's one of the discussions in Africa, and that's why one of the issues that we will hear our policymakers and scientists talk about is all about climate justice. And if you can remember in the first news, in that slide where we are sharing what is happening on the news, you could see that one of the presidents in Africa was calling for more climate change financing. So it's like some scientists, some communities, particularly once they know that, okay, we are paying too much for what that we have not contributed to, so they would expect, okay, now if you want me to protect my forest, then you have to pay me. And that's why the issues of, for example, when there was this policy, the reducing emission from deforestation, forest degradation, people would consider it because there was a possibility of being paid for whatever is being done in the developed world. So basically, if I may make it short, is that not some, but majority of people in our side would expect the developed world to pay or to support more because they are the ones who have contributed more on what is happening. So we are actually accepting that this has happened, and we are also feeling the pain, but we expect more support from those who have caused the pain. So if it happens that some are lagging behind, for example, in climate financing, it makes some of the communities here sad because, okay, so now we're experiencing this and those who have caused it are doing less. So in short, this is what is happening in our side. We expect some financing to help us deal with the impacts. And we also expect some commitments to encourage us protect the resources, for example, the forests, because yes, there are things we need it, and we are forced to protect it because of what has been done in the developed world. I hope I have answered on what
Thank you.
We are thinking.
Thank you so much. I saw one very important question I also think related to the climate, but there's all kinds of very good and very important questions. But the one that, if it's possible to still take it, even though I realize it's approaching 4, the question here is, can we only depend on natural sinks of greenhouse gases like CO2? So is it a must? Is only the sinks going to resolve the storage? And indeed, the real problem with CO2, other than nitrous oxide and methane, who are broken down in the atmosphere, CO2 is not broken down in the atmosphere. So the only way to take CO2 out of the atmosphere is for it to be taken up. Now, it can be taken up by the natural sources, the forests and the oceans. And there's a lot of research done currently to look if we can actually take it actively out of the atmosphere, but that is costing so much energy that the energy in CO2 emission with that is higher to take it out than it costs to take it out. So net, there's an increase in CO2 if we do this using non-natural resources, sinks. So yes, we are very much dependent, and this is also why even if we stop today with emitting greenhouse gases like CO2, it will still continue for a long time, climate change, and also we won't see a very rapid decrease in CO2 in the atmosphere. So we have a very long time before the temperature actually goes down. And this is why it's politically so difficult to tackle climate change, because politicians like short-term solutions, but climate and CO2 is impossible to solve at a short term. We need to think very long term, and we need to think how we can enhance the natural sinks. And because politicians like to think 4-year cycles, then they need to be re-elected, or 5-year or 8-year cycles. They don't want to think too much about climate, and even though it's really hurting society. And this is where it is a real difficulty tackling climate change with the long-term climate that we are facing, and really having to reduce the CO2 emissions now rather than later actively take it out of the atmosphere, if we even can in the future. So technological solutions are not the solution at this problem, at this stage, for CO2.
Okay, so we are 2 minutes past the time. I can see that there are a number of questions. I think maybe some we will have to postpone. Maybe you can answer on the group. If Mwangi, you can help copy these and post them on the group so that they can be answered there. We are supposed to end at 18 hours, and then now it's 3 past. So I'll have to end up here today. Thank you all for the questions and everything. And back to you, Mwangi.
Oh, yeah. We'll continue with the discussion in the WhatsApp group. Yeah, I believe a good amount of you have joined the group. Okay, thank you, Dr. Lilian Mulamula and Professor Karin Rebel for the insightful lecture and thoughtful, provoking lecture. I truly appreciate your time and valuable contribution to the acclimatized course. Thank you as well to the students who were active and engaged in the lecture, and we look forward to continuing these important conversations in the coming session. Have a wonderful afternoon. Thank you.
Thank you so much all for participating. Thanks.
Thank you.